Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher. So everybody, let me know in the chat box if I'm clearly visible and audible to all of you or not. Hi Abhijit, hello Girish, Nithya. Yes students, how are you all? So today we are going to do the second lecture of some basic concepts of chemistry, where we are going to start with mole concept, right? So students, let me know in the chat box if you all are ready for mole concept, because that is a very important concept that is applied everywhere in physical chemistry, right? Moreover, some questions mixed with mole concepts are asked in the exams, especially I'm talking about JEE Mains and JEE Advanced, right? Mix of organic with mole concept, then inorganic with mole concept, or some other concept of physical chemistry with the mole concept. Or if they ask you directly from mole concept, then definitely the question is going to be high level, right? Okay. Yes, definitely we are able to join. I hope so. You are here only. Uh, awesome, Subhi. Okay, great. So, guys, let me firstly see that how many of you have done your homework, right? I always see that. But let's see now how many of you have done your homework. Last time I taught you, wait a minute, I taught you some basic concepts of chemistry, law of chemical combination, where it is in the live, where it is, yes. So let me see how many of you have completed that. Let us see that, let us see that. Okay, can I see someone, what is the duration of this session, ma'am? Maybe around 1 hour or maximum 1.5 hour. Totally depends if you are able to understand things in easy manner, or if I have to go in detail, then it will take 1.5 hour. If you're like able to understand things very easily, then it will take 1 hour, right? Okay, so I can see the answers here. First is very good, Sanjay. Then Marut Ram, he has done 1 and 2 question both. That's great. Tarun has done the question, very good. Then you have Turup has done the questions. Solu Chand has done the questions, and Bhuvan Raj has done the questions. Okay, so these are the students that I can see are very disciplined by themselves only, right? So that's great that you are doing your homework. I'm very happy to know that. Now, ma'am, what was the homework, right? So, guys, the homework was law of definite composition is also known as what, right? Let me see what you guys have answered. You guys have answered. You guys have answered it. Let me see that. So answer will be law of definite composition is multiple, no. Avogadro's, no. Constant, yes. So answer is C. And how many of you have answered C? Tarun, then we have Marut, then we have Tirip, then we have Solu Chand, Sanjay, Bharat, and Bhuvan Raj, right? So next is 1 gram of oxide A combined with this much of A, right? Here what you have to apply is law of, I think, chemical combination. 1 gram of oxide A combined with this much of A, a 4 gram of another oxide A contained this, okay, this much of A. I think this should be contained. It should be contained here. 1 gram of oxide contained this much of A. 4 gram contained, 4 gram of another oxide contained this much of A. The data indicates reciprocal, constant, multiple, definite proportion. So as you can see, if 1 gram contains 0.5, then 4 gram will contain how much? 4 into 0.5. So can you tell me 4 into 0.5 will be what? 4 into 0.5 will be 2, right? 0.5 into 4 will be 2. So the first oxide, if I talk about, in 4 gram, you have 2 gram of A, right? But in the another oxide, in the second oxide, you have 4 gram has 1.6 gram of A. That means the composition must be different, right? Like you have H2O2 and H2O. So that defines the law of multiple proportion. So answer is going to be C is the correct answer. Is that clear to everybody? Right? C is the correct answer. That means different formulas will be there even if you have the same oxide, same A, like you have H and O. One you have H2O2, other you have H2O. So same thing is there, but you have different this much of oxide contains different amount of oxygen, this much of oxide contains different amount of oxygen, right? So this defines that the formula will be different, and hence it is a law of multiple proportion, right? Okay, and how many of you have answered this one correctly? Let me see that. You have answered B, C, C, C. Most of you have answered C only, right? Only one or two students have answered B. That means that was clear to everyone, right? That's great. Now, talking about the mole concept, right? Before mole concept, I'll just conclude 2-3 things here, right? First thing is you should definitely know one thing here, that what exactly is AMU? What is AMU? AMU is nothing but it is atomic mass unit, right? That defines the mass of one atom, right? That is atomic mass unit. So you can say AMU is atomic mass of one atom, Ma'am, then what is U? If you just represent U, that is nothing but mass of one molecule. Because we can't define for one molecule, we can't write AMU. So that's why we just write U. That is your mass of one molecule. Mass of one molecule. Then I'll talk about other terms that you will see in your mole concept. Then next term is one is AMU, right? Then you have gram atomic mass, and you have gram molecular mass. Right? Let's talk about gram atomic mass and gram molecular mass. If you talk about gram atomic mass, right, that is nothing but gram atomic mass is also mass of one atom or one mole of atom. That will be 1 mole of atom. 1 mole represents a specific number, right? That means if I say I have 12 bananas, I can also say 12 bananas. I can also say 1 dozen of banana. That defines 1 mole. You can just remember that 1 mole, we will see that in detail. But for now, 1 mole is nothing but that represents the, wait a minute, I'll just see you here, right? 1 mole is nothing but that defines, like we have 1 dozen eggs means 12 eggs. 1 pair of shoes, or you talk about 2 shoes, that is the same thing. 1 gross pencils, or you talk about 144 pencils, that is the same thing. 1 mole atom is nothing but 6.022 into 10 raised to power 23 atoms. That is defined as 1 mole, right? So if you talk about this concept here, ma'am, EMU is mass of 1 atom, right? If I have just one atom, its mass is called this much AMU. If I talk about mass of 1 mole of atom, same atoms, but I have taken 6.022 into 10 raised to power 23 atoms here, then that will be your gram atomic mass. Okay. Similarly, you have gram molecular mass. Now, what is gram molecular mass? That is nothing but mass of 1 mole of molecule. That means, let's say I am talking about any molecule. Let's say I am talking about O2. Let's say this is O2 molecule, right? So when I talk about 1 molecule, what is the mass of this 1 molecule? Just 1 molecule. That is your mass of 1 molecule, that is expressed as AMU. We define it as U, right? But if you talk about gram molecular mass, I am talking about the same molecule, but this molecule multiplied by 6.022 into 10 raised to power 23. This much of this molecule defines the gram molecular mass. Is that clear to everybody? Now, let's talk about these two terms. Now, let's talk about one more term. We have discussed gram molecular mass. Then there is molar mass. Then there is molar mass. Now, ma'am, what is molar mass? You just get confused in these terms. It actually means the same thing only. Okay. So, molar mass, if you talk about molar mass of atom, right? Molar mass of atom. And here I am talking about molar mass of molecule, right? What is that? Molar means 1 mole. So that means we are calculating for 1 mole of atom. What is the mass of 1 mole of atom? And here we are calculating 1 mole of molecule. 1 mole of molecule. Okay. Now let's see how you will tell the units here. What will be the units? But before units, you should know the numeric value here. Okay. So firstly, let's calculate for oxygen atom. Okay. You want to calculate for nitrogen atom, we can talk about nitrogen atom as well. Any atom you talk about, let's talk about nitrogen atom. Now the mass of one atom of nitrogen is 14. So it will be 14 AMU. But mass of 1 mole of nitrogen is nothing but 14 gram. Right? That's why it is just written gram atomic mass. In this case, what we replace in gram, replace AMU with grams. You just have to replace AMU with grams. The numeric digit will remain the same, right? The numeric will not change here. The units will only change here. Only units are going to change, right? 14, 14. But here AMU represents 1 atom, gram represents 1 mole of atom, right? When we are calculating molar mass, ma'am, that is the same thing, mass of 1 mole, 1. So 1 mole of atom. So here also it is 14 only, but we represent it by gram per mole. No difference it is. Gram per mole you write, gram write is the same thing. But here when we say gram atomic mass is this, automatically we are talking about 1 mole only. That's why the condition was, I'll tell you why we have different definitions for this. Simple thing is, when we defined AMU to gram atomic mass, they said that replace AMU with grams. And what we found out that, for example, you had this thing. For example, you have this thing. Okay, this is 1 atom, right? Now this is also 14. This is replace 14 AMU with 14 gram. Now they calculated that if we calculate, just see this thing very carefully. They said that this is 14 AMU, this is 14 gram. Just replace AMU with grams. Now see that how many atoms you will have in this 14 grams. And we calculated that the atom is coming out to be 6.022 into 10 raised to power 23. That is 1 mole. So gram atomic mass is not defined that calculate for 1 mole, though it is the same as 1 mole, but it is the reverse of that thing. When we talk about molecular mass, they said that, okay, what is the mass of 1 mole? We said that it is 14 gram per mole, right? But when we talk about gram atomic mass, they said that if you keep the numeric value same, if you change the units from AMU to grams, then how many atoms will be there? We said 1 mole atom only. So that's why the value of gram atomic mass and molar mass is same only. Because in gram atomic mass also you have 1 mole only, and in molar mass also you have 1 mole only. Got this point, guys? This is a very important thing, right? Usually students get confused that what is the difference in all these things, right? Now if I talk about any N2 molecule, right? 14 into 2, 28, but here I am talking about 1 molecule, so it will be 28U. In gram molecular mass, I will replace this U with gram, that will be for 1 mole. And in molar mass also, I am talking about 1 mole will contain how much? So that will be 28 gram per mole. So that is going to be the answer. Okay. Ma'am, if 2 moles occurs, then 1 mole is this, 2 moles is 2 multiplied by that thing. Right? 2 multiplied by that thing. Right? Okay. That thing is clear to everybody about the general terms that we will see in mole concept. Right? Now, see one more thing here that is very, very important for you to know. That is, I'll just write it down here. We talk about AMU, AMU, AMU. But ma'am, what exactly is AMU? Right? Ma'am, what exactly is AMU? So AMU, see, it's very difficult to find the mass of one atom. Right? So we compared the mass of one atom. Because mass were we compared with the different atoms, we compared the mass of one atom with different atoms so that we can define the mass in simple terms, right? So firstly, we compared all the masses with hydrogen atom, right? With hydrogen atom. But it was not right. Why? Because the mass was coming out to be in fraction. That's why we were like, if we have to learn this in 1.18, 1.926, 5 by 8, then what's the point of making new masses, right? We wanted simpler units. So that's why we compared it with oxygen atom, right? Now in oxygen atom, the mass were coming out to be in simple digits only. But the problem was that scientists questioned that whether we are talking about oxygen 16 or oxygen 18. That was the question. That what you're talking about, oxygen 16, oxygen 18, what is the reality here, right? So that is the reason, because then scientists explained that we were talking about oxygen 16 only. Then they said that why you didn't tell us before? You should have told us before, right? That's why this was also eliminated, because confusions were there. Some scientists were using oxygen 18, some scientists were using oxygen 16, and the confusion was already spread throughout the world, right? That's why they came up with carbon 12 isotope. And that's why it is specially mentioned that, because here the confusion was regarding isotopes only, that which isotope you are using. So when they compared it with carbon 12 isotope, because carbon is also very abundant, right? That's why they used carbon 12 carbon. Now they use carbon 12 isotope, they have specially mentioned it. And they said that 1 AMU is nothing but it is mass of 1 by 12 of carbon 12 isotope. That is EMU, right? Okay, so that is the definition. The mass of 1 by 12 of carbon 12 isotope is called atomic mass unit, right? Now, after calculating that, what we got is that 1 AMU is nothing but it is reciprocal of 6.022 into 10 raised to power 23. That means it is reciprocal of Avogadro's number. That is the number of particles. This is nothing but this is Avogadro's number, right? This is number of particles in 1 mole. In 1 mole. So basically, firstly what they did, they understood that what should be the value of 1 AMU. So I'll just also write down the value of 1 AMU also. Just give me a second. The exact value, let me just see. AMU. One point 1.67, where should I write? That was coming out to be 1.67 into 10 raised to power minus 24 grams. That is your 1 AMU. If you see, now we observe that in 1 mole you have these many particles. That is the Avogadro's number. And 1 AMU and Avogadro's number was inversely proportional to each other. right? So that was found out by the scientists. Okay, so that's why we directly also write that 1 EMU, 1 EMU, 1 EMU is inverse of 1 by NA. That also you should remember. Okay, understood everybody? This thing is clear to everybody. What is 1 AMU? How we calculated 1 AMU? The value was coming out to be this one. That this value is inverse of Avogadro's number, right? Okay. Now let's start our main concept of mole concept, right? So now mole concept 47 questions in last 10 years from the basis of physical chemistry reoccurs throughout the chemistry, right? So now let's talk about mole concept. What is one mole? That is defining the some specific number of particles, right? Like you talk about 12 eggs, that is nothing but we are talking about 12 bananas or 12 eggs, that is nothing but one dozen, right? You talk about one pair or you talk about two shoes, you talk about 144 pencils or you talk about one gross pencils, that is the same thing, right? Similarly, one mole is nothing but 6.022 into 10 raised to 23, that is your one mole. Now, whenever we talk about one mole, right? One mole is simply a unit for counting entities at microscopic level, right? Because we talk about atoms, molecules at microscopic levels, right? So one mole of any particle. Now this any particle can be atom, this can be a molecule, this can be electron, this can be proton, this can be neutron, anything this can be, right? Now this one particle, right, we are talking about this much particle, right, that is nothing but one mole, right? Okay, it is the amount of substance that consists of as many species as there are atoms in 12 gram of carbon 12, right? So that is nothing but your one mole. So this might be confusing for you. So atoms in 12 gram of carbon 12 isotope. So 12 gram of carbon 12 is what? That is your gram atomic mass. Okay? That is defining one mole only. 12 gram. 12 gram means we are talking about the same digit because one atom of carbon 12 has mass 12 AMU. Right? So 12 gram is nothing but we are talking about 1 mole. And 1 mole is nothing but 6.022 into 10 raised to 23. So by just to confuse you, they have written it contains as many species as there are in 12 gram of carbon 12 isotope. Right? Okay. Understood everybody? This point is very, very important for you to remember. That's why I explained you the basic terms in the starting only. Because they can give you, to confuse you, they can make the question like that. For I have to understand that if they are saying something like this, they are saying nothing but 1 mole only, right? Ma'am, why only they have written 12 gram of carbon 12? Ma'am, why not they have not written 16 gram of oxygen 16? Because the definition was given, the definition of 1 AMU was given in carbon 12 isotope. When we define AMU, we define it in terms of carbon 12. So that's why we have written carbon 12 only here. Otherwise, if you talk about 16 gram of oxygen 16 is also having 1 mole. It's not wrong. But according to the definition, we will specify carbon 12 because by convention, carbon 12 is taken. Right? Okay. Yes, everybody. Very good, very good, very good. Yes, that is the difference between micro and macro. Okay, now let's understand. Let me firstly tell, just let me know in the chat box if till now whatever we have discussed, because even if you have even small problem, any problem in whatever we have discussed, then you can let me know. Otherwise, what will happen? I'll just proceed to the next level and you will not be clear with what we have learned before. To summarize everything, we have one AMU. We defined one AMU for carbon 12 isotope, right? 1 AMU is the mass of one atom of carbon 12, right? That is 1 by 12 of carbon 12 isotope, right? Okay. Now that is defined as 1 AMU, right? 1 AMU is basically, you can say, if you talk about 1 AMU, that is 1 by 12th of carbon 12 isotope. Okay, chalo, I'll just write it here as well, right? Just to summarize things, what we have learned till now. Okay, what we have learned till now, I'm just summarizing that. If you have any problem in that, then you can let me know. Because these things are very, very important for the base of physical chemistry. See, firstly, we talked about 1 AMU. 1 AMU that was defined for 1 by 12 of carbon 12 isotope. Okay. If you see in reality, carbon 12 isotope is nothing but it is actually having 12. Mass is 12. This is 1 by 12. So that means 1 AMU is, that's why it is written as 1 AMU. Right? Because 12 will cancel out. This is the way of like writing definition is difficult. Right? Okay. So 1 by 12th of carbon 12 isotope. Now, why they have not written 1 by 16th of oxygen 16? They have written it, but there was some confusion. That's why it was eradicated. Now, why they have not simply written that 1 AMU is equals to mass of hydrogen isotope, hydrogen 1 isotope, right? It was not written firstly because isotope was not mentioned, and the other by this definition, the fractions formula, we were getting mass in fractions. So that's why this was eliminated. That's why we defined it as 1 by 12th of carbon 12 isotope. After that, we talked about that 1 mole is in terms of, because I know the confusing part is carbon 12 isotope. So 1 mole is 12 gram of atoms in 12 gram of carbon 12 isotope, right? Ma'am, why this? As I told you, 12 gram is nothing but we are talking about gram atomic mass. Gram atomic mass is defined for 1 mole. So they are saying nothing but 1 mole only. It's just the way of writing things is different, right? I think those atomic mass, gram molecular mass, that is easy. But this might be difficult for you. So that's why I have written it here. And remember that 1 AMU is equals to 1 by Avogadro's number, right? Okay, students, clear? Now, we are going to understand what is mole concept, right? Let's understand what is mole concept. Sure. Let's understand what is mole concept. For mole concept, now, I'll give you a simple definition here, right? Nothing, we are not going to a tough, difficult things. We'll make it very, very easy. Okay. Now, this is mole concept. First, let me just copy paste this also. I don't want to erase it again and again, right? So, this is your mole concept. This is mole concept, right? That is dependent upon 3 things. In mole concept, we link everything with mole. We link everything with mole. Everything is linked to mole. Now we have 3 formulas for that, right? And in these 3 formulas, what we have, one is regarding mass. If you convert, always it is going to be given by molar. Given by molar. This is also given by molar. Always in the formula, it's given by molar, given by molar, given by molar. Given by molar. Now, one formula will be in the terms of mass. So, you can write it as given mass by molar mass, right? One formula is in the form of particles. So, it will be given particles by molar particles. One formula will be in the form of volume. So, it will be given volume by molar volume, right? Okay, that's how you're going to write all of them. Now, tell me what is molar particles? How many particles in 1 mole? We have defined the number of particles in 1 mole as Avogadro's number, that is 6.022 into 10 raised to power 23, or you can write Na, that is your Avogadro's number. Right? Okay. Now, let's write down, ma'am, what is molar volume? Now, molar volume will have different answers, right? Let me just write it down here. It is mostly written as 22.4 liter. Then given volume also should be in liter. Okay. Now understand one thing. If you talk about molar volume, you can also write it here. Molar volume, right? Molar volume can also be 22.7 liter, right? If they have mentioned one, like if they have mentioned 1 atmosphere, you will directly at 22.4. It is basically volume at STP, standard temperature and pressure. Now, depending upon temperature is 2273 Kelvin or 298 Kelvin. This is 1 bar or this is 1 atmospheric. This changes, right? But usually we write it as 22.4 liter only, right? Okay. Usually we write it as 22.4 liter only. That is your full case of mole concept, right? First, you need to know 3 formulas here. That is given mass by molar mass, particles, given particles by Avogadro's number, given volume by 22.4 liter. Condition is they have given this in 1 atmospheric and standard pressure, standard temperature is 273, right? Okay. Now, if you see that, ma'am, what exactly we are going to do here. So let's understand this thing here. 1 mole of species, number of particles, this all we have already done, right? That was found experimentally. That is called reciprocal of Avogadro's number is known as Avogram, right? Now, let's talk about molar mass. Every single term we'll talk about one by one. First term is molar mass. If you talk about molar mass of every single species is different, right? For example, for hydrogen, the molar mass is 1. For oxygen, the molar mass is 16. For nitrogen, the molar mass is 14. For carbon, the molar mass is 12. Then for sodium, the molar mass is 23, right? Then for chlorine, the molar mass is 35.5. What else? Right? What else? What else? You can, have then oxygen also we have done. Main elements I have written here. That is your molar mass. Now, if I have to define molar mass of molecules, right? For example, I talk about H2O. That is nothing but it is 2 into 1, that is for hydrogen, plus 16, that is oxygen. So it will be 16 plus 2, that is 18. What about sodium chloride? Sodium is Na, chloride is Cl. So it will be 23 plus 35.5, that will be 58.5. So whatever molar mass when we are calculating, we will add the molar masses of each atom, and that will be your molar mass, or you can also say molecular mass. Okay. Now, that was about the mole concept. I have given you a better table for that. You can also go through this if you're able to understand this. Otherwise, I would advise you the chart that I have given you here, that is a beneficial chart for you, right? Okay. That I would write it here, right? Now, understand one thing, the STP. I told you about STP, right? Standard pressure and temperature. STP means standard temperature and pressure. Now, very important thing, standard temperature is 0 degree, 273 Kelvin. Standard pressure is 1 atmospheric. In that case, we take 22.4 liter. If nothing is given, they have just given STP. You will take 22.4 liter only. Right? Okay. Let's say they have changed the temperature to 25 degree or 298 Kelvin. Then it will be 22.7 liters. But very, very rarely you will use that. right? Usually STP means 1 atmospheric and 273 Kelvin only. So that's why we take it as 22.4 liter only. That is your molar volume, right? Okay. Now let us see how to multiply and how to use division in this case. What all we have to do, and that we will understand with the help of questions. Okay, students, so let's start with the questions, right? Beta, yeah, we are going to discuss questions only here. है ना? I can't just directly teach you questions without telling you the concept that what we are going to do, right? So now we are going to start with the questions, okay? Chalo. Let's start with the questions, because without any question, you won't be able to understand anything, right? Questions will help you to understand things in a better way, right? A piece of copper contains 6.022 into 10 raised to 24 atoms. How many moles of copper does it contain? Okay, let's see that. A piece of copper contains this much atoms, right? Moles of copper. So this is nothing but particles is given to you. So mole in terms of particle is nothing but given particles is 6.022 into 10 raised to 24. Avogadro's particles is 6.22 into 10 raised to 23. You cancel it and you will get 10. So the answer will be, you have 10 moles here, and that is going to be your answer. That is 10 moles here. Okay, please explain the difference between molecules and atoms calculation. Shiv Kumar, in what way you are asking me that? Very good, Paki. Yes, in what sense you are asking? About mass you are asking? What sense you are asking? Right? Okay. Yes. Now let's do this. Right? That is your 10 moles. Now let's see how many moles of oxygen atoms are present in 88 gram of CO2. Right? 88 grams of CO2. They are again asking you the moles here in this much CO2. Now they have given the mass. But in the starting, I am picking up very simple questions. Okay, so I want you guys also to answer this. Moles is given mass by molar mass. Given mass is 88. Now molar mass of carbon dioxide is carbon plus 2 of oxygen. So that is carbon is nothing but 12. 2 into oxygen is 16. So that will be 12 plus 32. That is nothing but 44. So it will be 44. It will be cancelled, and answer will be 2 mole is the correct answer here. Is that clear? 2 mole is the correct answer. That is the moles. Okay. Now let's. It should be. Wait a minute. How many moles of oxygen atoms? They're asking you the oxygen atoms here. This is basically moles of carbon dioxide. Wait a minute, I'll just write it here. This is nothing but this is moles of CO2, because we have given mass of CO2 by molar mass of CO2. So number of moles of CO2 will come out to be 2 moles, right? But they are not asking you the moles of CO2. They are asking you the moles of which thing? They are asking you the moles of oxygen atom. Now you have to apply unitary method here, right? Now students, let's apply unitary method. How to apply unitary method here? Very simple way, right? You will say that 1 mole of CO2, if you take 1 mole, it has 2 atoms. 2 atoms of oxygen, right? 2 atoms oxygen, right? If you talk about 2 moles of CO2, how many moles of atoms are present in 88 gram of CO2? So 2 moles of CO2 will have 4 atoms of oxygen, right? So answer is going to be 4 is the correct answer. 4 moles, or you can say 2 moles have 2 mole of 2 atomic mole, 2. You can also write it as 1 mole of CO2 has 2 mole of oxygen atoms, right? So I'll write it as 2 mole oxygen atom, right? So this will have 4 mole of oxygen atom. Is that clear, everyone? Is that clear to everybody? Ma'am, gram molar mass is equals to molar mass? Yes, Ram. Gram molar mass is molar mass only, right? Is that clear, students? So answer will not be 1, it will be 4. Okay, it should be 4 mole. 4 mole of oxygen atoms you have. Okay. Now let's see the next thing, that is a sample of hydrogen. A sample of helium gas occupies 5.6 liters of volume at STP, right? So let's calculate this thing here, and you guys also try to calculate this. What you have is a sample of helium gas occupies this much liter at STP. How many moles of helium does sample contain, right? So moles, again they are asking you in terms of volume. It is given volume is 5.6, at STP volume is 22.4, right? You divide it and you will get your answer here, right? How many moles helium does, or moles of helium does the sample contain? Easily you can calculate. Mole is equals to 5.6 divided by 22.4. Calculate this and you will get your answer here. Let me see after the calculation, which should I repeat? Which one, beta? Tell me what is the problem that you are getting here. 0.25 mole. After solving, you will get 0.25 mole. 0.25 mole. That means after solving, you will get 1 by 4. That is 0.25 mole. Okay? Which one? What is the doubt? Okay? That tell me that so that I can repeat that. We are using 3 formulas, I told you. Right now, I'm picking up very simple questions, very basic questions I am picking, so that you get habitual of applying mole concept. Right? Till now, we are just using the formulas of mole. We have not used mole concept till now. Just the formulas of mole you are using, that what is mole in terms of volume, mole in terms of mass, how to calculate if particles are given to you, how to calculate that. Okay? Now, we are going to start with calculate the weight of the following sample, right? Now, these are the questions that will help us to understand the concept better, right? Okay, students, so one by one we are going to calculate this, right? So let me just copy paste this slide here so that we can calculate. First is 100 atoms of carbon. 100 atoms of carbon. They are asking you the same thing here. Calculate the weight of following sample, right? Now, if you see 100 atoms of carbon, in sometimes we will apply unitary method, sometimes we will apply mole concept, right? You have to just understand things here, right? That's why the definitions were very important before that, right? Okay. How to improve this concept? Practice as many questions, right? Okay, I have just started with the basic level, but we'll go to the advanced level. Don't worry about that, right? So the first question, that is 100 atoms of carbon. For that, tell me one thing, one atom of carbon, because you will never know that in which question you will apply mole concept. Throughout physical chemistry it is applied, right? So one atom of carbon is nothing but it is 12. One atom is 12 AMU, right? It is 12 AMU, right? Now, if you see, it is 12 AMU, one atom is 12 AMU. 100 atoms will be what? 100 atoms of carbon will be nothing but it is 12 multiplied by 100 AMU. That is 1200 AMU. But that we have answered in AMU. Okay, this we have answered in AMU, that will have 1200 AMU as the answer, right? Now, let me see if they have mentioned anything. 100 atoms of carbon, they have not mentioned anything, so we will not even get into it. We can also solve this in the terms of grams. I'll tell you how. Okay. Now we are going to solve the same thing in terms of grams. If the option, if they have given in AMU, then you will solve it like this. If in the option they have given in grams, then how you will solve it? If they have given in grams, 100 atoms of carbon, we are talking about how much mass in grams they will have, right? So what you can simply say that 6.022 into 10 raised to power 23 atoms will have how much mass, beta? How much mass in grams? 6.022 into 10 raised to power 23 atoms will have how much mass in grams? Mass in grams will be nothing but 12 gram, right? So one atom will be equals to 12 divided by 6.022 into 10 raised to power 23. 100 atoms will be equals to 12 by 6.022 into 10 raised to power 23 multiplied by 100. Solving this, you will get your answer here, right? Now, ma'am, can I also calculate the same thing from this calculation? Yes. Acha, what I told you, what is one AMU? One AMU is the reciprocal of Avogadro's number. So can you calculate the same thing? 1200 multiplied by 6.022 into 10 raised to power 23, right? We know that this 1 by 6.022 10 raised to power 23 is nothing but it is 1.66 into 10 raised to power minus 24 grams, and that's how you will get your answer in grams. Okay, that's how you have two methods I have given you. You can calculate like this. You can calculate like this. That's totally your choice how you want to calculate. The main important thing is that the concept should be clear in your head, right? Here I have not used any formula. I have answered it with the help of calculation, with the help of definitions. Okay. Now let's see the next thing here. Next thing is 0.5 mole atoms of sulfur. 0.5 mole atoms of sulfur. 0.5 mole atoms of sulfur. Right. Now this is your sulfur. 0.5 mole atoms of sulfur we have. Now students, see this concept very carefully. If you talk about 0.5 atoms, right, mole is given to you. Mole is given to you, right? Now how we will apply this? Mole is given. We need to calculate the weight, right? So for weight, what we can apply, mole is equals to number of moles of sulfur atom is equals to mass of sulfur atom divided by molar mass of sulfur atom, because they are talking about atoms. So means we will calculate for sulfur atom only, right? So mass of sulfur atom is nothing but 32. Weight we have no idea, we'll calculate. Number of moles is given to be 0.5. So weight of sulfur atom will be 0.5 multiplied by 32. That is 16 is going to be the correct answer here. That means for 0.5 moles, you had 16 gram of sulfur atom, right? Okay. Okay, students. Right. Unitary method, where I have applied unitary method? Unitary method is always, for example, x gram, x is given to you, and for y you have to find out. What you will always do, let's say they have given you in 100 gram you have 2 atoms, right? So you will always find for 1 gram. Okay? Firstly, always whenever you in unitary method, always you compare it with 1. Okay? So if you have 100, 200, whatever you have here, you will calculate for 1. Then that will be 2 by 100. If here you have 100. Now let's say you want to find out for 50 grams. So 50 gram will be multiplied here. I think that you must have learned in your like earlier classes in 9th class. It's still I am repeating it for you, right? So that is your unitary method. You always compare with the unit, right? That is 1. And then the value that you want to find out, you multiply with that value, right? Okay. Okay. Can I watch the video from now? Will understand for me, ma'am. From now, that totally depends. If you are like completely blank in mole concept, then guys, no. If you still have an idea about mole concept, then yes. Right? Okay. Now, next is 8 gram of atom of oxygen. 8 gram of atom of oxygen, weight is clear, only 8 gram is given to you. So that is there only. Then 25 AMU. 25 AMU, what is the mass here? 25 AMU is given to you. You have to calculate the weight here. So 25 multiplied by 1.66 into 10 raised to power minus 24 gram is going to be the weight in grams. Okay? Yes, everybody? Yes, everybody. Let me know in the chat box if that is clear to everyone or not. If that is clear, then let me know in the chat box. Now let's start with the next question here, right? They have given you among 10 raised to power minus 9 gram, each of the following elements, which one will have the highest number of atoms, right? They have given among this much gram each of the atom. That means weight is same, right? They are saying which one will have the highest number of atoms. That means simply you have to tell, see, simple thing we will apply here, right? We know that number of moles is equals to number of particles by Avogadro's number. Avogadro's number is constant, that is 6.022 into 10 raised to power 23. So that means, can I say number of moles? Can I say moles is directly proportional to the particles? Particles. Because Avogadro's number is constant. And we know that here particles are nothing but they are talking about atoms, right? So I'll just directly write here, that means we are talking about atom. Okay. Among 10 raised to power minus 9 gram each. Now if you see one thing, mole in terms of mass is given mass by molar mass. Mass is constant. Mass is constant. Mass is constant. Molar mass is changing as the atom will change, right? Molar mass is changed when the atom will change. That means, can I say mole is inversely proportional to the molar mass? Molar mass. So mole is like your mummy, right? Always you have to compare everything with moles. Now, what was given to us? Given was mass, and they were asking about particles, right? Now they are asking you which one will have highest. This should be highest. Then this should be low. If this is low, mass is constant, moles will be high, then number of atoms will also be high. That means you have to calculate lowest molecular mass. Which one will have lowest molecular mass? That will be your answer. Now you have to tell me which one will have. Jay, please don't spam in the chat box, right? You will not get anything if I say your name, right? Nothing will happen in the world, right? Okay. Yes, everyone. Ma'am, why we multiply with 1.66? There we multiplied with 1.66 because EMU, the value of 1 EMU is nothing but that is 1.66 into 10 raised to power minus 24. That's why we multiplied it with that. Okay? Understood? Okay. Yes. Now you have to calculate the value which has lowest mass, right? So same thing, we need to get the lowest mass. Molar mass of praseodymium is 141, very high, right? Platinum 195, Pb, lead is 207, then you have polonium, that is 209. Out of this, the one which has the lowest mass among them is the one that is praseodymium, right? So answer will be A is the correct answer here. That is your JEE Mains 2025 question. Okay, understood how based on mole concept they have, given you the question, right? First thing was the mass. You should know that, you will know from periodic table, right? For that periodic table, inorganic chemistry you have to understand, right? See, can you see in JEE mostly the questions in JEE Advanced, so for sure the question will be mixture of two concepts. In JEE Means also you have two concepts. One is you should know the molar masses. Other is you should know what exactly is the relation. For relation, you should know the mole concept here that I have taught you here, right? Okay. Now let's talk about the next thing, that is calculate the number of atoms, electrons, protons in 67.2 liter of CO2 at CO2 gas at STP. Right? Ma'am, how to remember molar masses? That I'll tell you in periodic classification. Right? That we will learn that in periodic classification. That is the concept of inorganic chemistry. Okay? Simple thing, yeah. Nothing to worry. Tell me one thing. Mole is two things, right? Mole is also given mass by molar mass. Given mass by molar mass. Mole is also number of particles by Avogadro's number. Now they have given that the mass is constant. That means this is constant. This is also constant. So this variation only I told you that mole is inversely proportional to molar mass, directly proportional to particles, and particles here are in the form of atoms. So that proportionality only I told you. They are asking you which will have the highest number of atoms. If this should be highest, then this should be lowest, right? That's why we are calculating the lowest molar mass here, right? Okay, yes, Rama, I will definitely make that. Okay, yes. Beta, that I'll tell you in inorganic chemistry, okay? That's the mixture, okay? That I'll tell you in inorganic chemistry, okay? Right now, don't worry about that, okay? Yes. Calculate the some important general molar masses. That is very simple. Carbon is 12, oxygen is 16. They are general atomic masses. But if you have to calculate that which one will have higher and lower, you don't have to. Firstly, see, let me be very clear to you. You don't even need to remember this. Okay? That's not how periodic table I'm going to teach you, that you have to. Some masses you have to remember, like aluminium, sodium, magnesium, calcium. All these 1 to 30 you have to remember. Bromine, chlorine, these are some important things that you should remember, right? But when I talk about platinum, lead, polonium, praseodymium, right, ma'am, should I remember this? You don't have to remember this thing. All you have to remember is the placement in periodic table. Placement in periodic table. Because once you know the placement of atoms in the periodic table, you will be able to understand which one will have lower mass, which one will have higher mass. So that's why I'm telling that have patience. I'll tell you this in periodic table. Once you are able to draw the periodic table, you will be able to understand that this element is placed here. Out of them, it has the lowest atomic number. So lowest atomic mass will also be there. Generally, this happens. Okay? Right? Okay? Yes. Now, let's move towards the next one, that is calculate the number of atoms, electrons and protons in 67.2 liter of CO2 at STP. Students, see, let's calculate this. Let's understand this thing, right? For that, let me just take out one blank page here, right? Okay. Number of atoms, electrons and protons. What we want to calculate, number of electrons, atoms, protons. Okay. So firstly, I'll talk about atoms. Okay. In 67.2 liter of CO2. Let's talk about this. Now, bacha, mole concept is nothing but it is about moles. So whenever anything is given to you in the question, they have given you volume, they are asking you atoms, they are asking you weight, anything they are asking you, you can calculate. All you have to calculate first is moles, right? Whenever there is a question on mole concept, right, you have moles, volume, mass, atoms asking, you have to firstly, so whenever you have any problem, you go to your mom, right? So mom is nothing but moles. Okay. Moles is like a mother to you. You always call your mother whenever you are in trouble, right? And here, whenever you are in trouble, you will always call mole, right? So now we will firstly call mole, right? You'll have to calculate moles. And moles of what will be? Moles of CO2. Because number of atoms they have given you, volume of CO2 is given to be 67.2 liter. Volume of CO2 at STP is given to be 22.4, or you can say molar volume. Molar volume at STP is 22.4 liter. Right? From that, you can calculate the number of moles of CO2, that is 67.2, 22.4. Calculate this. What is the number of moles that you are getting? Right, 66.67, na? 67.2 divided by 22.4, it is coming out to be 3, right? Now, that is 3. Number of moles of CO2 is 3, right? 3 moles. Once you have number of moles, you can calculate anything. Trust me, anything. Now, once you have number of moles, we also know that, can I calculate the mass here? Though they have not asked me the mass in the question. I am just telling you what all we can calculate. From one question, I want to teach you everything here. That's why I am taking up example of one question so that you can understand a lot of things from just one question. Okay? Understood? Yes, everyone. Now, once you know, you have called your mom, everything will be solved. Right? So here, number of moles of CO2 is nothing but given mass by molar mass of CO2. Now, can you tell me what is the molar mass of CO2? Everybody, what is the molar mass of CO2? Molar mass of CO2 is 44. Number of moles of CO2 is 3. And given mass, I am taking as W of CO2. So weight of CO2 is nothing but 44 into 3. That will be something 4, 3, 12, 12, 132, I think. 44 into 3, yes, 132. So answer will be 132 gram will be the weight of CO2. Okay. What if they ask you also weight? Right. Now, from moles, we can calculate volume, we can calculate mass, we can also calculate particles, right? Now, understand particles very, very carefully, because this is where students end up doing mistakes, right? Students, we have number of moles of CO2. So, in particles, tell me, we will have atoms or we will have molecules? Tell me, students, we will have atoms, any atoms, 22, very good. Now tell me, will we have atoms here or will we have molecules here? We are talking about a molecule here. So we'll talk about, this is number of CO2 molecules. Understood? If number of moles of oxygen atom you have, then you will say number of oxygen atom divided by Avogadro's number, right? So this will be your number, this will be your 6.022 into 10 raised to 23 atoms. But here this is going to be 6.022 into 10 raised to 23 molecules. Because the moles are we are calculating the moles for a molecule. So things are going to be in terms of molecules. That's why the general term we talk about particle. Particle can be atom, it can be electron, it can be proton, it can be ion, it can also be atom, anything it can be. It can be a molecule. Okay. Okay, students. What I am telling you, that if you have, let's say, number of moles of carbon atom, if the moles you are calculating for atom, then here you will write number of carbon atom divided by 6.022 into 10 raised to 23 atoms. But if I say number of moles of oxygen molecule, then it will be number of moles of oxygen it will be number of particles of oxygen molecules divided by 6.022 into 10 raised per 23 molecules. Got it or not? Is that thing clear to everybody? Why I am writing here molecules? Because right now you are in the initial stage, right? I know that when you will you tend to mistake, right? Tend to do mistakes, right? We are often like, okay, we are thinking that, okay, just quickly, what is the big deal now? I can easily write atoms here, right? These are very silly mistakes that I have seen students doing, right? Even when they are in class 12th or even droppers do the same silly mistakes, right? So don't do these silly mistakes. Here we are talking about NO2 molecule, CO2 molecule. So here will be molecules and here also it will be molecule, right? Now, once you are clear on that, number of molecules N of CO2 is nothing but it is given to be 3 moles. 3 moles. So, it is number of CO2 molecules is going to be 3 into Avogadro's number. That is, it is nothing but 3 into 6.022 into 10 raised by 23 CO2 molecule. Okay, 6.022 into 10 raised by 23 CO2 molecule. Now see what they have given you. Calculate number of atoms, right? Calculate number of atoms, guys. Number of atoms you have to calculate here. Let's see how we will calculate the number of atoms here. Okay, how you will calculate the number of atoms here. Let's see that. Firstly, you need to understand one thing, that if we are talking about number of CO2 molecules, it is going to be 3 into, I am simply writing Na, that is your number of molecules, right? Now see, if you talk about how many atoms, how to write it, you can say in one CO2 molecule. How many simple atoms you can see? You can see 3 atoms. It is triatomic. It has 1 carbon, 2 oxygen. So you have 3 atoms, right? So if you have these many molecules, how many atoms you will have here? In 1 you have this much. In 3 into Na CO2 molecules, you will have 3 into 3 Na atoms, right? That is 9 of Na atoms. That is going to be the answer here. Is that clear to everybody? That is going to be the answer here, right? Okay. Now these are the total number of atoms. What if they ask, ma'am, how many carbon atoms you have? How many oxygen atoms you have? Then see, one CO2 molecule will have 1 carbon atom. So 3 into Na CO2 molecule will have 3 into Na carbon atom. That means 3 into Avogadro's number multiplication carbon atoms. Ma'am, what if they ask us, ma'am, oxygen atoms? Then what we will do? So one CO2 molecule will have 2 atoms, 2 oxygen atoms. In one CO2 molecule, you have 2 oxygen atoms. So in 3 into Na molecules, you will have 3 into Na into 2 oxygen atoms. Oxygen atoms. That will be 6 into Na oxygen atom. Is that clear, everyone? Is that clear, everybody, or not? Right? Is that clear to everyone? How to calculate oxygen atom? See, any molecule they can give you, right? Any molecule. They could have given you, let's say, H2O, right? In H2O, how many atoms? How many molecules? See, anything. They could have given you HNO3. In one HNO3 molecule, you have one atom. In one HNO3 molecule, you have one nitrogen atom. In one HNO3 molecule, you have 3 oxygen atom. That's how you answer things, right? Okay, in the similar pattern, you will answer things, right? Now, another difference that can be there in the question, here we answered the number of CO2 moles with the help of volume, right? They could have also given you the mass here. This is the mass. Calculate the number of moles. From the number of moles, calculate the molecules. From the molecules, calculate the atoms. Anything they can ask you to calculate. Okay? Right, everybody? Tell me in just one question. I am not taking multiple questions and then in again different question. I'm teaching you different things. I'm taking just one question where I'm teaching you every single thing that you need to know from mole concept. Okay, is that clear? Because now we are going to move towards electrons and proton calculation, right? That is little bit beyond your mole concept, right? Okay. Yes, everybody. Raj, my offline class is my online batch only, where we teach in an offline manner only. That is our Sigma batch, right? There we teach our students, right? You can see the details of Sigma batch in the description box here. That's where I teach, right? No offline classes, YouTube and Sigma batch, right? Okay. Yes. Now, let's see this. Ma'am, how to calculate, ma'am? They were also asking about number of electrons. Just pick out the molecule. From that only, apply unitary method. See, in one molecule of, in one CO2 molecule, tell me how many electrons. In one CO2 molecule, how many electrons are there? In carbon and oxygen and oxygen. These are the electrons that you need to calculate. Carbon has how many electrons? 6 electrons. Oxygen has 8 electrons. This has 8 electrons. So it will be 8 to 16. 16 plus 6, that is 22 electrons. Right? 22 electrons. So can I say that one CO2 molecule has 22 electrons. 3 into Na molecule will have 22 into 3 Na electrons. It will be 22 into 3, that is 60 to 66 into 6.022 into 10 raised to power 23 electrons will be there. Right? Okay, that's how you calculate the electrons. Right? Okay. Now see one thing. One thing very important. In one CO2 molecule, how many protons? 22 protons you will have. Right? So similarly, you can say 3 into Na molecule will have 66 into Avogadro's number of protons. That is the same thing. Because in a neutral species, number of electrons and protons are equal. Right? In a neutral species, number of electrons and protons are equal. But when we talk about a cation and an anion, then what happens? Let's say you have CO2, 2 negative. You have added 2 electrons here, right? So, one molecule will have 22 plus 2, that is 24. So, instead of multiplying 22, you will multiply with 24. But remember that whenever you make a cation or anion, only electron changes, proton will not change. Electron, when you have a cation, you take out electron. When you have an anion, you add the electron. You can't change the proton. You can change the number of electrons there, right? So only electrons will vary. And because of that electrons, this composition will change. This will not change. Okay? Understood, everybody? Understood, everyone? Right? Right. Okay, so that's how you can answer things here, right? Okay, everyone, let's see how many questions we have. 2, 3, I think 4-5 questions we have. Let's do that. Okay, so let's do that. The concept I have taught you right now, we are just going to do more questions on that, right? In the last question, I have told you every concept that was needed for mole concept. Now we will see how differently they can ask you the questions, right? Calculate number of ions in zero point 0.1 mole of AlCl3. Ma'am, ions, ma'am, how to calculate? Array, ma'am, ions, how to calculate, ma'am, ions? Ma'am, you have just given a different concept only here. Whenever ions, electrons, they ask, you don't need to worry about anything. Just relax, right? Because we know that AlCl3, one molecule dissociate into Al3 positive plus 3 of Cl negative. That is together 3 plus 1 is 4, right? So that's why just calculate the number of molecules of AlCl3, right? So number of molecules, we will calculate. Firstly, we will know the number of moles is 0.1, right? So number of molecules will be molecules, you can say molecules of AlCl3 divided by Avogadro's number multiplied by 0.1. So molecules of AlCl3 will be 0.1 into Na. That is going to be your molecules of AlCl3. Okay, that is going to be the molecules of AlCl3. Now we know that in one molecule, in one AlCl3 molecule, how many ions it is giving? How many ions? One molecule is giving 4 ions. So we can just write 4 ions here, right? So now 0.1 AlCl3 molecule will give 0.1 into 4 ions. That is nothing but 0.4 ions, and that is going to be the correct answer here. Okay, right, everybody? Understood this or not? See, I am giving you different type of questions. In every single question, you're learning something new, right? No time wastage we are doing here. The same concept repeatedly I am not teaching you, right? So every single question we are getting something new. Electrons, protons, right? Now ions, how to calculate from mole concept. Okay, everybody? Vasuki, I think now you will find it very difficult to understand. So I would advise you to re-watch this lecture, right? Achha, how many of you have hit the like button? Let's see how many, like how much target you have achieved for the likes. 72. Very good. Let's make it 100. Okay, let's make it 100, right? Because time, it takes time to pick out questions from you, to take out the best questions, so that the flow of the lecture is good, and so that you can learn by every single question you can learn something new, right? So it takes efforts, right? For that effort, I want you to also like this session, share this session with your friends, subscribe to this channel, also get along with let's take out new friends, let's take out new subscribers here on this channel, so that we can also feel motivated, no? Right? Isn't it? Share this on your WhatsApp, share this on your Telegram. You can also tag me on your Telegram channel when you put up the story while I'm teaching. You can tag me @Diksha. I will love it totally. I will also reshare your story. Right? Okay? Yes. Ma'am, you deserve 1 lakh. Like, thank you so much, yeah. Thank you so much. Right? Thank you. Okay. So that was done. Now let's see the next question here. That is JEE Mains 2028. You know why I always pick out JEE Mains questions also, so that you can get this confidence that we are not solving random questions here, right? From the starting, we talked about AMU. Now we are solving JEE Mains previous year question, and we are not solving very old questions. We are solving latest questions. Okay, so that will help you to understand that what is the pattern, what kind of questions they ask, right? A sample of NaClO3. This is a sample of NaClO3 is converted by heat to NaCl with a loss of 0.16 gram of oxygen. The residue is dissolved in water and precipitated. This, the mass of AgCl in India obtained will be given molar mass as this. Now, firstly, you have to understand the question in itself, right? Okay, then we will think about the answer. So read this question again, guys. Read it again. Try to understand by yourself also, right? Whenever I am teaching, why I teach at a very slow pace, so that you can also understand understand by yourself also, not only when I am teaching you. A sample of, this is the sample, is converted by heat to NaCl. Okay. So you have NaClO3. That is, after heat, it is converted to NaCl. Right? That means decomposition is happening by heat to NaCl with a loss of this much of oxygen. Loss of oxygen also we have done. The residue is dissolved in water, right? The residue is dissolved in water and precipitated. This is the residue, right? This is dissolved in water and precipitated as AgCl. AgCl is taken out here, its precipitate is formed, right? The mass of AgCl in grams will be, now this mass they are asking you. Mass of this AgCl they are asking you. Right? Okay. What do you do after this session? After this session at 8 p.m. we have our class 12 session. You can watch that. You can watch the previous session of physics, chemistry and maths. You can do the homework, right? So many things to do, right? So now molar mass of AgCl is given to you. Mass they are calculating. Can you get this hint here that you actually have to answer the number of moles of AgCl? This is what you have to answer. Number of moles of AgCl is what you have to answer. Now, the mole concept is shifted to the reaction. Okay? Mole concept is shifted to the reaction. Okay, let's see this. Firstly, I have to balance this reaction, right? Let's say you have 2 of this. If I multiply this with 3, this with 2, then this will be multiplied by 2. Right? Now, oxygen mass. See, simple thing is, if this is 2, then this is also 2. Now, firstly, balancing is required. Okay. Why balancing is required? Because this stoichiometry, this is the stoichiometry. This stoichiometry is telling you the number of moles in a standard reaction. Okay. Whenever I am saying that H2O is formed by H2 plus O2, this is half of O2, right? That means I want to say that half mole of O2, 1 mole of oxygen, 1 mole of H2 and 1 mole of water is formed, right? So why balancing the reaction is so important? Because we are talking about stoichiometry here. This is giving you in the standard reaction, by this rebalancing, half mole of oxygen, 1 mole of hydrogen will give you 1 mole of water. Understood why we balanced it? First, you tell me if you're able to understand that why we did the balancing. Okay? Are you able to understand why we did the balancing? Right? Okay? Now, because we have already done the balancing, now you know things will be very simple. Now you will say, ma'am, it was such an easy question. We thought it's very difficult. Now it is very simple. Now this is given to you. This is asked to you. Okay? And now you will have Diksha ma'am's trick, right? Simple trick. Where should I write my trick? Right? I need to have a blank page. I need to have a blank page. Okay, here we have the blank page. See, given, I'll just give you a simple trick here. Not even trick, I would say. A simple format how you should answer things. Okay, a simple format of answering things. Right? So, see this here. Whenever something is given to you and something is asked to you, firstly, whatever is given to you, given can be mass, volume, particles, atoms, molecules, whatever is given to you. Firstly, calculate the moles of given. moles of what is given to you. Then apply unitary method. Apply unitary method. Then calculate the, let me see if I am able to delete this. ठीक है? हाँ. Now, अरे भाई, wait a minute. What just happened? I think guys, just give me a second. I think I did something which I should not have done. Uh, hmm. Correct. Wait a minute, guys. I think I'm stuck somewhere. I think, wait a minute. Uh, guys. I'm stuck somewhere. I have no idea how to. I know why my mouse is moving itself by itself. I'm not doing nothing, bro. Why you're moving by yourself? I don't know. Just to explain you what I have done here. Just give me a second. I'll just ask the team that what has happened here, right? So just give me a second. I'll just send the photo of what is happening here, right? Or I have to restart everything. Then just give me a second. I think I'll have to restart everything here, right? Because I'm not able to understand what has just happened, right? So my screen is like, ma'am, please study CS. Even I feel I need to study it, you know. Even I feel that I need to study computer science now. I need to study like full technical support now. I don't know what has happened here. Oh my god, it's fine now. Okay, it's fine. It's fine. Okay, great. Wait a minute. But still, am I able to? But still, it is moving. Wait a minute. Sometimes I feel that in my class there is some booth. Wait a minute. Instead of a blank screen, we will like to carry something here. Right? Let me just see what has happened. Uh, 25th. Guys, just give me a second, right? Ma'am, what is the meaning of stoichiometry? Stoichiometry is when you have a balanced chemical reaction. What is given? Like I told you, 1 mole of H2 plus half mole of oxygen gives 1 mole of H2. So that is stoichiometry, right? Stoichiometry is the digit that is written in a balanced chemical equation in front of the compound, right? That is your stoichiometry. Okay. Chalo, I think sometimes I feel that, you know, what is more important? Ma'am, which thing? Important is experience. है ना? Important is experience and jugaad. Right? I think with the help of jugaad, we are able to manage the problem that we faced. Right? Yes, we did it, guys. We did it. Awesome. Right? We did it, guys. I hope so. Now I will not do any mistake here, right? Okay. So great, we did it, right? Now back to the basics, back to the question, right? So ma'am, what is stoichiometry? Beta, this is stoichiometry, right? This is stoichiometry, this number that is written in front of the compound in a balanced chemical equation, that is stoichiometry. For now, you can understand this thing. In detail, I'll tell you more about it, right? As we proceed through the lectures and the chapter, I'll tell you more about stoichiometry. Right? Now understand one thing, whenever one thing is given to you, whatever is given to you, they may have given you mass, they may have given you volume, they may have given you particles, anything that is given you, first you will calculate the moles of what is given to you, right? Then you will apply unitary method and you will calculate the moles of what is asked to you. Once you calculate this, then after that you will calculate either the volume or mass or particles, anything you can calculate. Okay? As I told you, always when you are in problem, always call your mom. And here the mom is moles. So whatever is given to you, you will firstly calculate the moles, then apply unitary method, then you will calculate the moles of what is asked to you. Then from that, if they have just asked the moles, good. If they are asking volume of that compound, if they are asking mass, if they are asking particles, you can easily calculate from moles. Right? So moles is your main proper thing from where you will calculate the different things here. Right? Okay, I don't want to lose my information, bro. Why are you not responding? You have to respond because we are responding to you. Okay, chal. Now let us understand what you will do here. Okay, let's understand, ma'am, what we will do in this case. Right? Okay, students. Now, if you see this here, can you see this? Number of moles of given, what is given to you? Can you calculate the number of moles of what is given to you? Can you calculate that? See, it is 0.16 gram of oxygen. So we can calculate number of moles of oxygen is given mass divided by molar mass, and that will be 0.01 moles. That is going to be the mass of what is given to you. Sorry, moles of what is given to you, right? Once you know the moles of what is given to you, what I asked you, apply unitary method, calculate moles of what is asked to you, right? Now you have to find a relation between oxygen and AgCl. What is the relation that you can see? The relation is that 3 moles of O2 and 2 moles of AgCl you have here. Okay, so that thing we will say that we can say that 3 moles of O2 is equivalent to, once you have 3 moles of O2 here, you will have 2 moles of AgCl, 2 moles of AgCl, right? So moles are 0.01. So 1 mole of O2 will give rise to 2/3 moles of AgCl. 0.01 mole of O2. This is unitary method. This 3 mole, then calculate for 1, then multiply with what is given to you. 0.01 you have to calculate. 2/3 multiplied by 0.01 is the correct answer of moles of AgCl. Okay? Understood everyone? Right? That will be the answer. Now, you can just solve it. They have asked you the mass or what? They have asked you the mass. Acha, they have asked you the mass of AgCl. You know the moles of AgCl, right? That moles of AgCl will be 2/3 into 0.01. I am not solving this here. I am just directly calculating, right? Number of moles of AgCl is equals to mass of AgCl. Mass of AgCl. You can also write it like this: mass of AgCl by molar mass of AgCl. So mass of AgCl is, number of moles is 2/3 multiplied by 0.01. Now molar mass of AgCl. Can you see that? What is the molar mass of AgCl? That is 143.5. So you can see 143.5. Just do this and you will get your answer here. Right? Okay. Yes, students. Okay. So you will get your answer here. You can easily calculate that. Okay, right everybody? Moles of NaCl is this. Wait a minute. NaCl plus AgCl. Oops, one mistake we have done here. What is that? I have taken 16 here. It should be 32. It should be 32. Because we are talking about O2 now, it should be 32. Right? Should be 0.01 divided by 2. Right? That will be the mole. Okay? That will be the moles. Right? So here it should be 0.01 divided by 2, and here it should be again 0.01 divided by 2, right? And then here also it should be divided by 2, and that's how you will get your answer. Okay, yes everybody, ma'am, please repeat this problem. Are nothing. What they are asking you, they are saying that you have this much of NaClO, right? That is giving you NaCl and O2, right? And you have AgCl precipitates out, right? So that's why we balance this equation first. We calculated that after balancing what we got, if you balance this here, right? Now what is given to you? What is asked to you? First you will calculate the number of moles of what is given to you. Then you will calculate the number of moles of AgCl. From that, you will calculate the mass of AgCl here. Right? This is what we did here. First, you will calculate number of moles of O2. Then we applied unitary method. Then we calculated number of moles of AgCl. Then again applying the formula, we calculated weight of AgCl here. Right? Okay, that I have already taught. Molarity, no, I have already taught you that. Right? Okay. I have not taken it like this. I have solved it in a different way, right? So you need to worry about that. You will get the same answer only, right? Okay, let's see if you're getting the same answer or not, right? You get the same answer only here. Don't worry about that. That will be 1 by 300 into 143.5. So I have solved it in a different way. So you can just erase this thing as well. Otherwise, you will get confused only. Okay? I have solved it in a reaction method. I have not given you like, okay, this is NaCl and this. This was the reaction. Firstly, I balanced this. Then I balanced because this is 2 NaCl. This is also 2 AgCl. Because to replace one Na with one Ag, that means one NaCl will give you one AgCl. That's why if it is 2, this is also 2. Right? Okay, students, is that clear? Right? Is that clear? This is a very important question. Right? Firstly, calculate what is given to you, number of moles, then apply unitary method. For 3 moles, you have 2 moles. For number of moles that you have calculated here, how much moles of AgCl will be there? From AgCl, calculate the mass of AgCl here. Right? And that's how you will get your answer. Number of moles of AgCl, then calculate this and you will get your answer here. Right? Okay. Got it, everyone? This is the important thing that you have to apply everywhere, right? This is the concept what I used here, right? Given moles, unitary moles asked, right? Okay. So, next question is your the ratio of masses of oxygen and nitrogen in a particular gaseous mixture is 1/4. The ratio of number of their molecules is what? Ratio of masses of oxygen and nitrogen. Mass they have given you, mass of oxygen and mass of nitrogen in a particular gaseous mixture is 1/4. They are asking you the ratio of number of their molecules is what? Masses is given to you. Molecules you have to calculate. See, for molecules, what you have to see is, for molecules, we know that if you calculate this, number of moles is given mass by molar mass, and this is molecule by molecule, na? This is Avogadro's number, right? So that means number of molecule is nothing but this is multiplied by Avogadro's number, right? Now masses is given to you. They are asking you to calculate the ratio of their molecules, right? So if you see, Can we see number of molecule is equals to given mass by molar mass multiplied by Avogadro's number? Can you see this thing here? Because mole is equals to particle number of molecules by Avogadro's number of moles is also is equals to given mass by molar mass. So from that, can I see this definition here? Right? This is the formula. Now, number of molecules of N2O2, O2 na, O2 by number of molecules of N2 is equals to mass of O2 by molar mass of O2 multiplied by Avogadro's number. Here also it is mass of N2 multiplied by Avogadro's number divided by molar mass of N2. This will cancel, and we know that the ratio of masses of both is going to be 1 by 4. Mass of N2, what is the mass of N2, guys? What is the mass of N2? Mass of N2 is nothing but it is 28. Mass of O2 is nothing but it is 32. Right? So calculate this 214 into 2, 7. Right? Okay. Then that's it. You have your answer. 7 by 32 is the correct answer. That is D is the correct answer. Okay. Right? See, different type of each question is a different type of question. Right? So that every single minute that you're spending on this video, on this, whether you're watching recorded version, anything, that should be useful for you. Right? That is our main motto here. So answer will be D is the correct answer. This is your JEE Mains 2018 question based on mole concept. Right? Next is a gaseous mixture contains 60 mole percent of CO2, 40 mole percent of O2. Calculate average molar mass of the mixture. This is actually not related to this concept here. What is mole percentage? Mole percentage. That is nothing but mole fraction. A gaseous mixture contains this much of CO2, this much of O2, average molar mass of the mixture. See, what you have is, this is nothing but this is mole fraction of CO2. This is nothing but this is mole fraction of O2. Okay? This is actually not related to this concept. I think by mistake it is repeated. Right? This is not related to the mole concept. This is related to concentration terms. Okay? So that's why I'm just, because there's a repeated question this is. Right? Mole fraction of CO2 is given to you. Mole fraction of O2 is given to you. You have these two formulas. Right? Mole fraction is number of moles of that compound divided by total number of moles. Right? And what is the average molar mass? That is nothing but that is M1 into N1 plus M2 N2 divided by total number of moles. Right? So what you have to calculate here, right? Just put in the value, right? We are just replacing this in the form of mole fraction. Okay, so if you see, this is N1. If you just replace this here, this will be M1, N1, meaning this N1 plus N2 is also divisible by M1, N1, is also divisible by M2, N2, right? So can you also write it in the form of M1, N1 by N1 plus N2 and M2, N2 by N1 plus N2, right? Now, this is nothing but this is mole fraction of 1, this is mole fraction of 2. Mole fraction of 1 we have written as CO2, mole fraction of 2 we have written as O2. So both the mole fraction, you put in the values here that is given to you. You put in the mass of M1. M1 is nothing but CO2, that is 44. For oxygen, the mass is 32. For this, the mass is 44. You put in the values and you will get your answer for average molar mass. Okay? This concept is not related to mole concept, but I think by mistake it is here. So you need to worry about it. I think by mistake the question is here. Right? But still, because it was there, so I taught you that. Right? Now, JEE Mains 2025 question that is based on, this is also based on your molarity only. I think by mistake we have this question again here. So look, no worries. We have completed concentration terms. We have completed mole concept. So that's good that we have these kind of questions here. Right? 10 milliliter of 2 molar NaOH solution is added to 20 milliliter of 1 molar HCl solution kept in a beaker, right? Now, 10 milliliter of this mixture is poured into volumetric flask of 100 milliliter containing 2 mole of HCl and made the volume up to mark with distilled water. The solution in the flask is how much molar? So first you need to understand that what is all they have given you in the, what actually they are saying this in the question, okay? So 10 milliliter of 2 molar, 10 milliliter of 2 molar, right, of NaOH we have, right, 20 milliliter of 1 molar of HCl we have, okay? Now, beta, we know that from the concentration term concept, we know that number of moles is equals to, molarity is equals to number of moles by volume in liters, right? Okay, volume in liters. If volume is in milliliters, we will calculate here millimoles. Millimoles. If volume is in milliliters, right? So can I calculate that number of millimoles? Millimoles. Can easily calculate here. Millimoles of NaOH is going to be 10 into 2, that is 20, right? Millimoles of HCl is going to be 20 into 1, that is again 20. Both are 20 millimoles, that is clear, right? Till here we know that is clear. Now 10 ml of this mixture is poured into volumetric flask, right? Now you take this mixture, you add 10 milliliter of this, 20 milliliter of this, right? Now you pour this mixture, 10 milliliter you take out. Let's say you have 2 beakers. This is 10 milliliter of 2 molar. This is 20 milliliter of 1 molar, right? You mix these two things, right? You have a new mixture which is 30 milliliter, right? Now you take out 10 milliliter from that, and from that is poured into volumetric flask of 100 milliliter containing 2 moles of HCl. Now that is into volumetric flask of 10 milliliter, 100 milliliter containing 2 moles of HCl. That is of 100 milliliter, that is the volumetric flask volume. But the HCl is only 2 moles, right? Now made the volume up to this. That means you have made the volume up to 100 milliliter, right? Now they are asking you the solution in this is how much molarity. That means first you have to discuss that when you mix 10 and 20, what will be the molarity of this mixture, right? When you neutralize, because these two will be neutralized with each other, right? So that's why molarity M1, V1 will subtract from each other. So what we will have, this is NaOH, this is HCl. You have this neutralization reaction here, right? This is the neutralization reaction here. NaOH and HCl give rise to NaCl and H2. That is your neutralization reaction, right? Now, if you see this here, that was, you can say 20 millimole or 0.2 mole, that is the same thing, right? Okay, so because 20 millimole is nothing but, when you divide it with this, it will be nothing but 0.2 mole. That is the same thing, right? Okay, so this will be your 0.2 mole, this is 0.2 mole, this is 0.2, this is also 0.2, right? This is also 0.2, right? That is given to you. Now, resulting solution will become neutral because the number of moles are same here, right? Number of moles are same, then what will, see, if number of moles of strong acid and strong base are equal, H positive and OH negative will cancel each other and the resulting solution will be neutral. Okay, this is live beta. Okay, so from here, either you calculate 20 millimoles or whatever, the moles are same, the solution will be neutral, right? You will have a neutral solution here. Now, 10 mole of above solution is poured into flask containing 2 mole of HCl, right? So you are taking out 10 milliliter of that, right? Made the solution till 100 milliliter will distill water. Now what you will do, molarity of HCl will be 2, that is the number of mole, divided by volume, that is 100 milliliter. Because what we are doing is we are taking out 10 milliliter from that. 10 milliliter of neutral solution you are taking out. Okay? 10 milliliter of neutral solution you are taking out. Right? You want to calculate the molarity of this solution. Right? So for the molarity of HCl, we know that neutral solution will not participate in the molarity of this. So that is going to be, because what we are adding here is 100 millimoles here. So answer will be number of moles is 2, 100 is the volume, multiplied by 1000. Simple molarity formula we are using is equals to 20. That will be your molarity of the solution. Okay, because we are adding a neutral solution here, we pick out 10 milliliter here, right? This was the beaker which had 2 moles, right? And we know that molarity is equals to number of moles by volume. If it is in milliliter, this will be multiplied by 1000 here. So answer will be 20 molarity, because neutral solution will not participate in changing the molarity here, right? Okay, so that's why that was the important thing. So we have 20 molar HCl solution there, right? Now, ma'am, what if we have acidic solution? Ma'am, what if we had basic solution? Then things will change. Okay, that don't worry, we'll study about that in more detail in ionic equilibrium as well. You will study about that, right? Not now, but in ionic equilibrium you will study about that. Okay, yes, everybody got it or not, right? So we have discussed questions on mole concept. We have also discussed some 2 questions on concentration terms that I have already taken the lecture on, right? You can go and check that out. That's a very, very important lecture. Now, this is your homework that you can see. Number of atoms in the following sample of substance is the largest in this, right? Number of atoms they are asking you, mass is given to you. You have to use this formula. Number of moles is equals to mass given mass by molar mass, right? Okay, number of atoms means this is what they are asking you. Number of atoms, okay, by Avogadro's number. But understand one thing, right? For iodine, right? For magnesium, for chlorine, for hydrogen, right? The masses are going to be different. You have to also see which one is diatomic, which is only monoatomic. According to that, you will calculate the atoms, and that things will change. Okay, that you have to see for yourself. Iodine, I2, magnesium, Mg2 does not exist. Chlorine, Cl2, hydrogen is H2. Because they have not written here hydrogen atom. So we will take it as H2, Cl2, Mg, and this is I2. That's how you are going to calculate this. Okay. Here also you will calculate molecule, then convert to atom. Here you will calculate atom only. Here you will calculate molecule, then convert to atom. Molecule, then convert to atom. Okay. Yes. Yes. Chalo. Next is the SI unit of Avogadro's number that you have to tell, right? What is the SI unit? Kelvin per mole, unitless, both A and B depending upon context. None of the above. Avogadro's number that you have to tell. Okay? Ma'am, I feel better after this session. That's great. That's great. You were feeling better. Even I am feeling very much better after this session. You know, everything that is going on, right, even in our lives or whatever is going on, right, we are sad, we are happy, but when we are on this platform, when we are teaching you, right, things change, right, automatically. The stress, everything goes out, right, things become normal, because when I teach you, that is my therapy, right? Teaching is like my therapy, and studying, if studying becomes your therapy, that would be great, right? Because when you get to see that students are learning, they are happy, they learned something from your class, the happiness that a teacher gets, that is not compared with anything, right? So I'm so happy that you learned something from this session. And guys, if you actually learned, Please do this question. I know this question is time consuming, but I really want you to do this. It will take you 15 minutes, 20 minutes. Do this. You have time to do this, right? Okay. Then this is the next question that I want you to do. This you can easily answer within seconds, right? Let us see how many of you do your homework, and I would love to see your homework. And students, one very, very important thing for all of you. So many of you were asking about, ma'am, do you teach offline, right? Students, I have a batch. I teach in Sigma batch, Sigma JEE 2026 batch. This is for 12th and dropper students, right? You can get enrolled here, right? The fees is very minimal, that is 3,999 for full year, for full 1 year. This is the fees. We are giving you mock test, we are giving you live session, replays, and things are live. No recorded classes are there, right? And we are also providing you not only the live sessions, right? We are providing you DPPs, modules, test series, everything we are providing you. Along with that, we are also providing you this QR cards, right? From that, you can just carry them on your in your pocket, and you can revise wherever you want to, right? You are in the bus, you want to revise, you can revise, right? So that is the benefit. And if you are in class, ma'am, I am in class 11th, ma'am, what to do? Then students, very important thing you can see here, that our JEE Pro courses, you can see 20,000 flat off is there. JEE Pro, if you like 2-year course or 1-year course, now you will say, ma'am, what is exactly JEE Pro? This is flat 10,000 off for JEE 1 year, and for 2 year it is 20,000. Now you will ask me, ma'am, what is exactly JEE Pro? Right? I am telling you about 2-year course here. 1 year also has the same facilities, right? It's just that the time is 1 year, here the time is 2 years. So according to that, the syllabus, the pace will be according to that, right? Now students, here for those students especially who want to be like, ma'am, I am a distracted kid, ma'am, I can't do homework like that, ma'am, you need to watch that whether I have done homework or not. Ma'am, I have so many doubts when I'm solving the questions, ma'am, who will answer my doubts, right? Now, the problem is that some students, they are self-disciplined. They are like, okay, I'll do work on my own. There is no problem in that. Some students, they get distracted. They want someone to tell them every single day that you have to do this, right? To check their homework every single day, to see their doubts in person, right? Now, for those students, we have made this course that is Pro Batch for you. In this Pro Batch, what we are providing you is the guidance of where, like, it's like you're able to see me now, right? In this batch, I will also be able to see you in the batch, right? Your cameras will be on, your mics will be on, right? And one person will be monitoring you whether you are studying or not, right? Whether you're solving the question or not. Parents meeting, teacher meeting will be there, right? Full on personalized attention will be given to you in these batches, right? It will be like, if you're not able to, if you want to save your time to go to offline center, or like, ma'am, offline center is very far away from my home, right? But ma'am, I am not able to do self study, ma'am, that is not my thing, ma'am, I am very like, I need someone to be always on my head and tell me to study, then this is the batch for you, right? So all the parents, all the students, right, if you want to save your next 2 years, then this is the batch, that is our 2-year JEE course for 11th students, right? From 2025 to 2027, we are here with you. Live interactive classes, offline like discipline, hard copy books will be delivered to you, modules will be delivered to your home, right? Then 24/7 live video call doubt solving. This is the best feature, right? That is, anytime you're solving the question, you feel like, ma'am, I have this doubt. Now, ma'am is not available every time, right? So what we have dedicated mentors, right? You will have the access to doubt app, right? You can just call, video call, and from that side, the teacher will answer and solve your doubt in that instant. You are studying at 3 p.m., you are studying at 5 a.m. in the morning, doesn't matter. The teacher will answer your doubts. Okay, so that's why this is very, very important for those students who want to do hard work, but they need proper mentorship, proper guidance, especially for class 11 students, right? Why? Because right now you have just started, right? And class 12 students, we have two options. One is Sigma batch and one is your JEE Pro batch that I can see here, 10,000 off is right now going on here, right? So in JEE Pro batch, right, as I told you, you will have access to 24/7 doubt solving, and hard copies will be delivered to your house, right? And you will have your cameras, your mic will be on, right? You can ask your doubts in the class itself, right? The strength is limited in one session so that we can cater to every single student. In Sigma batch, right, we can't see you, but you can ask your doubts when we unmute you, right? And in Sigma batch, you have the option that you want soft copies or you want hard copies, and 24/7 doubt solving will not be provided, but doubt sessions will be taken within the batch, right? And in the class, within the class or in the replays of the class, you can ask the doubt. So that is the difference, right? Now the choice is yours, that what you want to opt for 2026 and 2027 aspirants. I have given you full detail regarding that, right? Okay, chal. I'll wait for your homework now, students. Till then, bye-bye, take care. And one more thing, this is our Telegram channel of JEE. You can subscribe to this channel because all the updates are provided here only. And I'll wait for your homeworks in the comment section. Till then, bye-bye, take care.